Hello everyone, welcome back. This is our video for the week. I just wanted to discuss your assignment. It's going to be quiz 3. So this quiz is going to be due 1 week from now at 11:59, so 4:24. It's going to have 10 questions. You'll have 5 minutes to do it and only one attempt. And it's going to be based off of the Lab 8 lecture and this intrinsic and extrinsic factors PowerPoint I'll be going over today. So one thing I want to go over real fast is for the discussion board assignment from last week, your food safety and news assignment. What I needed you all to do was put your food project, food, in the title there. So if you haven't done that already, then please make sure to reply and say what product you're going to be doing for your food project. And if you haven't done that, and you don't do that by today, you will be losing a few points on that, unfortunately, because that was part of the assignment. So for these ones is kind of how I wanted it. Okay, so with that, I want to go to our presentation. So this is going to talk a little bit about the intrinsic and extrinsic kind of factors that play a role in determining which microorganisms can grow and how well. And I think this will play a pretty important aid in your food project that you're going to be working on. So we have two different types of parameters, our intrinsic and our extrinsic. So the ones we're going to be focusing on are the intrinsic parameters, because those are actually related to your food product, whereas the extrinsic parameters are more related to the environment that your food product is in and the microorganisms. So what I want to go over today is just the intrinsic parameters mainly, because that's really what is going to assist you. This is a pretty long lecture, so I don't want to go over everything. If you want in your free time, you can take a look at it. Maybe some of the stuff will be able to assist you for your food project, but I just want to kind of briefly go over these different parameters so you can understand them, especially the intrinsic ones. So the first one is the pH of foods. So the pH of the food is going to affect which organisms can grow. So most organisms in general are going to grow at a neutral pH, so around 7 is neutral. So it's going to be a range of 6.6 to 7.5. And a few of them are going to be acid tolerant, and they'll be able to grow below pH of 4. So molds are going to be the most acid tolerant, also the most basic tolerant. So they're going to have a very large range that they can survive, and yeasts are going to be the second most acid tolerant. So molds can survive all the way down to a pH of 0, some of them, whereas yeast can survive all the way down to a little bit above 1, okay? So as here are pathogenic bacteria, none of them can really grow below 4, whereas our lactic acid bacteria can. So when we're fermenting our lactic acid bacteria, they're going to lower the pH, and this is going to help. So the pH is going to get down here, and it's going to stop any other bacteria that are pathogenic from growing, ideally. So our definition for low acid food is a food, if it's below pH of 4.6, then it can't grow Clostridium botulinum. Okay, so it's based off of Clostridium botulinum here, 4.6. Okay, so I don't want to go over anything else on there too much. You can just kind of see different ones. The ones that are really low are acidophiles. So here we can take a look at which groups, which kind of foods, so which food products. If you choose any of these food products, you can kind of see which pH your product is going to be. That'll kind of give you an idea of which microorganisms are going to be able to cause contamination. So if we look at which food group is more likely to be spoiled by bacteria, we can see that our fruits have a pH that is pretty low. Most of them are around 3 to 4. Some are a little bit higher, but the majority are around 4, I'd say. And then here, if we look at our vegetables, we see that they're a lot higher, up towards 6, and some of them even getting up to 7 with corn. So the pH of vegetables is going to be higher. So that is going to be allowing more bacteria to spoil them. Whereas with vegetables and fruit, when it comes to yeast and molds, both of these are going to be within the range of growth for yeast and yeast and molds because, as I was showing you earlier, yeast and molds have a really large pH range that they can survive. So the pH of fruits and vegetables falls well within this larger range, so both of them are going to be able to survive pretty easily. It's not really going to have a large effect, but it is going to, a lot of fruits are going to be low enough to stop bacteria from growing. Okay, so you can see some other food products. Same idea. Okay, so I'm not worried too much about this. If you do choose beef as your food product, you can take a look at this a little more. Okay, so low pH is going to kill microbes through these different processes. Okay, so our next intrinsic factor is moisture content. So that's the water activity. So hopefully by now you realize that water is required for all organisms at this point. And if you do remove the water, then the cell may die, or at the very least the growth will be inhibited, so it's not going to be replicating. So it can be very beneficial for our food products, preserving them. So the moisture content in foods is going to be described by water activity, which is just A subscript W. So it's just the ratio of water vapor pressure of the food substrate to the vapor pressure of pure water at the same temperature. You don't really need to know that, but it's good to know it's just the moisture content in the food. So the higher this water activity, the number, so the number is going to be based out of 1. So pure water is 1, and then anything lower than that is going to say that there's less water available inside that food product. Okay, so just based off this, we know that salt is down. Salt has a lower water activity, then dry fruits have a lower. So just by drying your food and adding salt to it, you can decrease the water activity. Okay, so in this table we can see the water activity required for the growth, so the very lowest amount of water activity that needs to be in the food for the organism to grow. So if we have a food that has a 0.9 water activity, then all 3 groups can survive. So we get bacteria, yeast, and mold growing. But let's say if it was a water activity of 0.85, then only molds would be able to grow. So the ones that's going to be most susceptible to a decrease in water activity are bacteria. So if you decrease the water activity, you won't be able to have bacteria spoil the food, but molds will still be able to spoil it because they can survive at a lower water activity, most likely. Okay, so which microbial group requires higher water activity to grow? So then it'll be, if we look here, bacteria is the highest, then yeasts, then molds. Okay. So how this is going to work is basically just going to change the osmotic pressure. So, okay, osmotic stress. So the next intrinsic factor is oxidation reduction. So this is also known as the redox potential, or capital EH. So this is going to be expressed in millivolts. So this is based off of oxidation reduction. I'm not going to ask you any questions about this, but hopefully you remember from chemistry. So really the big thing about oxidation reduction, how I think about it is the amount of oxygen available to the food, the amount of oxygen in the food, the availability of oxygen. So typically you'll find that the interior part of the foods is going to be more electronegative, lower EH. So this is because there's going to be less oxygen available on the interior part of the foods, but then on the exterior part there's going to be more oxygen available, so it's going to have a higher EH. And if there is a barrier such as skin on the food, it can also have effect on that because it's going to limit the amount of oxygen that's available. Okay, so here it shows you the different EH of different foods, so how reducing or oxidizing they are. Okay, so if it's reducing, it's going to be anaerobic, and then oxidizing is going to be aerobic. We can think about it like that. So aerobes are going to require highly oxidized foods. They're going to have a positive EH. And then anaerobes are going to require reduced conditions, and they're going to have a negative EH. Okay? So again, it's kind of like thinking about the oxygen preference. Okay, so you can take a look at these. This is how they survive. Okay, so the next intrinsic factor is nutrient content. So one thing that's important is that gram-positive bacteria are going to require B vitamins in foods to grow, whereas gram-negative bacteria and molds are going to be able to synthesize the vitamins that they need, so they don't need it in the food. So since fruits are low in B vitamins and a low pH, which microbial group would grow better in fruits? Okay, so we know that gram-positive bacteria require B vitamins, so if fruits are low in B vitamins, we know that they aren't going to be able to grow very well in them, okay? So you know, so for your food project, if you're doing a fruit, then you should know that there aren't going to be very many gram-positive bacteria, or there won't be any. So the next intrinsic factor is antimicrobial constituents. So these are just naturally existing antimicrobial compounds in the food. So for spices, we have eugenol, which is inside of cloves, cinnamon, sage. Then we have allicin, which is inside of garlic. Then we have capsaicin, which is in chili peppers. We have cinnamic aldehyde, which is in cinnamon. We have allyl isothiocyanate, which is in mustard, and then thymol, which is in thyme, sage, and oregano. Okay, so one of these is going to be on the quiz, so make sure you know. So you can see a bunch of different antimicrobial properties in spices. Okay, so this is the proportion of bacteria inhibited, and you can see that garlic, onion, oregano, all these have very high antimicrobial properties, or they can inhibit a large percentage of bacteria, a large proportion of them. So you can kind of see the effectiveness of each of these different spices. And that, so with that, this is just some interesting information, kind of just saying that these spices have been used in order to inhibit the growth of bacteria. So there's a correlation of temperature and spice. So, but that's only for spices that inhibit greater than 75% of bacteria. But if you're really interested, you can take a look at that. I'm not going to be testing on it. So these are all interesting as well. So if you're going to be doing any of these foods, you'll be able to use this information for your food project. So berries, fruits, they're going to have these phenols. Okay. So with that, that's just about everything that I wanted to go over for this. You can take a look. So the very last thing is the natural covering, just a biological structure basically. So like I was saying earlier, the skin of foods, or the shell, can help to protect the food from being spoiled. Not that crazy an idea. So if you do have a food product that does have a covering, a natural shell, or something like that, then feel free to talk about that in your project. Okay, so with that, that's really all I wanted to talk about, unless we can look at this example real fast. So with dried mango, we have a pH of 3.4 to 4.8, which is going to allow molds and yeast to grow, and some bacteria. And then we have a water activity of 0.6. So this is not going to be susceptible to microbial growth, which is the reason why dried mangoes can last for a long time, years compared to days or weeks for a fresh fruit. So it's going to be a positive value. It's aerobic. The nutrients, which are going to be rich in fiber and sugar, but it's going to be low in vitamin B, so it's going to not allow the growth of gram-positive. And then for antimicrobial, there may be phenolics because of it being a fruit, right? And then structure, with this product, there's not going to be any skin on it or anything, so there's no structure protecting it. So these are all going to be things that you can talk about for your food product. Okay, and then we have extrinsic parameters. So these are also things for certain products that are going to be important. So if you're talking about a bag of chips, then you could talk about the nitrogen environment that it's stored in, because they've pumped the bags full with nitrogen. And then for certain food products like meat, they have a modified atmosphere packaging map. It's going to use gases with antimicrobial properties, so CO2, O2, ozone, a bunch of different ones. And then non-vacuum packaged foods are going to be aerobic, and then vacuum packed foods are going to be anaerobic because the oxygen is removed. So just keep that in mind. All these things are going to play a role for your food project. And if you have any questions, please feel free to email me. Okay, one thing that might be useful is knowing the intrinsic and extrinsic factors that affect microbial growth. Oh boy. Well, good luck.